still sharing your screen.
Oh, of course. Of course I am. I'm very good at that. Sorry. My apologies. So, bivariate data. Collect data on the same person, same individual, in the form of an ordered pair. So like X comma Y. Explanatory. And of course response. As an example, let's say we're interested in the blood pressure of, let's say, people who smoke. Let's say number of cigarettes, blood pressure. So we measured both, so number of cigarettes smoked per day and the blood pressure, as an example. These two come from the same individual, number of cigarettes and the person's blood pressure. So that's what we're looking at today. Then I would like to discuss what a scatter diagram is, and we will start with producing one in the next few minutes. So a scatter diagram is when I have all the data paired, right? X comma Y on the same person, and I plot them. So this is a scatter diagram. I plot all the information that I had on every one. This is for one person, this is for another, this is for another, this is for another, this is, and so on and so forth. This is what is called a scatter plot. So a scatter plot, it gives us some idea of a trend. So that's what I already put in here for you. A graph of ordered pairs, quantitative variables, of course. It shows the relationship between those variables taken on the same individual. Okay, so I'm going to just give you a few examples of different scatter plots. So here's another example. Here's another. Here's another. So, what do we notice in the first one? That I could possibly draw a line through it. Possibly. Of course, he's not going to go through all these points or the pairs. Of course, he cannot. But I could say, well, it's a positive relationship, linear. It appears to be a positive linear relationship. I'm looking at this one, and I could approximate the data set with a negative linear relationship, or I could say it's a negative linear relationship. Of course, the line could never pass through all the points. What can I say about this one? What I can say is definitely non-linear. I cannot draw a line through it. I could possibly fit a quadratic model. But it's definitely not linear. What about here? What can I say? Absolutely no relationship. Absolutely. So this is what I meant with linear, positive, or negative, non-linear. And this is what I meant with no relation. So if you want to put those graphs here or not, it's up to you. Any questions so far? Okay, I would like to look at an example, and I would like us to put this very easy data set 8 entries, 2, 4, 6, 8, 8 entries. I'm gonna share my screen. We're gonna put the data in the in StatCrunch, and I have my calculator is charging, but I think it's gonna be good enough. And we're gonna put the data set in the graphing calculator as well. Okay, ready? So let me switch to my screen, share. And I think I already have, I lied to you. Sorry for lying to you. I'm sorry. I meant to do it, but I didn't do it. I thought I did. Didn't I? Oh, yeah. I just started to get there, but I didn't. Okay. So let's create a variable. Let's call it whatever you want, club head. Just read the idea. We are trying to see if there is any relationship between the club head speed and the distance of the ball. Okay. So let's enter, put a variable. I already entered my data. Last night when I wrote the handout for you, I already entered my info. So I have it. So I could go to my StatCrunch data, to my data, and I called it clubhead/distance. I'll wait for you to enter it. And here it is. I called it club head. I called it distance. Let me know when after you enter the data. Are we okay? Do we have all this? Do we have the data, everyone? Okay, good. Good. Okay. Does anyone else need time? Emma, you can enter it in, if you can enter it in the StatCrunch. So let's do this. So go to Stat and go to Edit and clear whatever. I put my data in far away because I fell in love with the previous. I should delete everything really, but I didn't want to. So just put the data where you want it to be. So in list L1 and list L2, make sure you have 8 entries in both. So this is to be understood 100, 257, 102, 265, 264, etc., etc. This data set. Do you want to dictate, or are we okay now? Yes? Anyone else needs time? Say it again. Yes. Yes. 257. 264. 274. 266. 277. 263. 258. And 275. Okay, so now let's go to graph and scroll down to scatter plot. We want to see how this data set looks like. We want to select the X variable, which is club head. We want to select the Y variable, which is distance. We just want to make sure that we don't need anything else here. obviously, let me make sure. Add to, nope. Display points, yes, we want to display points, yes. Point type, it doesn't matter. Fill circle is good. We want to write on the x-axis, yes, I do want to write on the x-axis if I find my keyboard. We want club head, or I want club head. You can label it the way you want. And I want distance. And yes, we can put a distance in yards. And the club head is the speed. So this is in miles per hour. So we know. And I'm fine with everything else. I'm just going to compute. And let's take a look at the data set. What would you say about, is there a relationship? It appears to be a relationship between the type of club and the distance that the ball can reach. Does it appear to be linear? Does it appear to be non-linear?
Linear.
Yes, it appears to be linear. It appears to be linear. Okay. So that's how we look at a scatter plot and draw some conclusions from it. Okay. Now I will stop sharing for a moment. We have something that is called a correlation coefficient. Correlation coefficient. What does the correlation coefficient tell us? It will tell us, number one, how strong the linear relationship appears to be. Relationship appears to be. Number two, if it is positive or negative. So if it is positive or negative. 3. The notation is R, and it can be between -1 and +1. This, if it happens that R is -1, strong negative linear relationship. Of course, for 1 is strong positive linear relationship. What if R is 0? No linear relationship. So of course, for the sample, as you already know by now, we have a notation, and the for population we have a different notation. RHO, rho, another Greek letter. So R is for the sample and rho is for the population. And we will determine it right now. However, how it is R determined? We are not going to look at the formula for the population. We only need the formula for the sample. Okay, I already put it for you here on page 3 at the very top. Of course, it's a sum from I equals 1 through n. The denominator is n minus 1. And this is a product. And this is the product of the z-scores. So the z-score for x times the z-score for y, for each and every one of them. This is what it means. So z-score for x for each one, and the z-score for y, each one. Of course, corresponding. When I is 1, z-score for x1 times z-score for y1. When I is 2, and then that's multiplication. when I2, the z-score for x2 times the z-score for y2, and so on and so forth. So, one time, let me stop my video because I got to 18 minutes.